Okay, so this the Compliance Summit, this is the first time we've done a Compliance Summit at reInvent. Thanks for everybody for coming. Really appreciate you being here. I'm Chad Wolf, the Director of Risk and Compliance for Amazon Web Services. And the purpose of this session really is to talk about lessons learned, get exposure to what other companies have done, what other agencies may have done to use the cloud to get through some of the compliance and security requirements, and then to hear from someone on my team with some thought leadership around compliance in the cloud with the public sector. So this is how the format is going to go today. You'll hear from each of our customers. Each person has about 7 minutes to present, and then Jen Gray on my team will do a presentation. After that presentation, there's a reception in the very noisy room next to us, because all those people are all excited about financial services. But you'll be able to follow these presenters to the next room, where you can then talk and ask questions. So normally we would have a Q&A session, but instead we'll save it for the reception in the next room after this main session. So I'd like to turn the time over to Justin to kick it off. Justin.
Hi, I'm Justin Ewald. I'm the Infrastructure Manager for Public Works and Engineering for the City of Houston. We've got some really neat things going on in Houston. We recently moved our utility billing system out to the Amazon cloud. There's two pieces to this. We have our billing, which we bill 500,000 customers every month, which produces $1.2 billion a year in annual revenue. The other piece of the infrastructure is our utility, our meter infrastructure. So before we had Amazon, we had vans that used to drive around the city of Houston, and we would collect water meters one time a month. Then we built a wireless system across the city, and we started reading these water meters every hour. So we went from one read a month to 24 times a day. That caused a problem. We quickly outgrew our infrastructure. We were producing billions and billions of water meter reads every year. So we moved this infrastructure out to Amazon. So we leveraged the unlimited computing capacity and the unlimited storage to be able to store all this information. And then with that computing, we started to be able to do some really, really neat things. Once we had that computing, we could spin it up if we wanted to run water analytics. So we started taking this data, and we started using it to tell if our customers had water leaks. We could run statistics on it. We could send text messages to our users if we thought their pipe was busted or leaking, which we were able to conserve vast amounts of water resources, as well as billing. So if a customer would call in and say that they had a high bill, before we only had one read a month. Now this was a problem because we didn't know when they used that high usage. Once we're able to take this data into Amazon and collect it and store it over 4 or 5 years, when a customer would call in, they would say, hey, I don't know why my bill is so high. We would say, well, last Tuesday you used 30,000 gallons of water. And they go, oh, I filled up my pool. They paid the bill. So it's working out really good for us. Some of the other initiatives that we're doing in the city of Houston since then, our Rebuild Houston initiative, it's an ordinance that we collect $115 million a year to rebuild the city of Houston streets and drainage systems. The most recent thing that we put out on Amazon is our electronic plan review. We just launched this last month, and what it allows our citizens to do is, from their home, submit architectural drawings for our permitting process, so they no longer have to go down to our permitting center to get that plan review. So how do we do it? We started small. We started out, our Rebuild Houston initiative was 4 years ago. It had to be done in 6 months, and I don't know if anyone else works in government. 6 months is not a lot of time. It takes us that long just to put requirements together and order hardware. So we decided to use Amazon. We created EC2. We established our VPC. We spun up just a few servers. We were able to go live with the initiative. We were able to build the servers within 2 weeks versus a year to get the hardware. we made the initiative successful. And then I think we realized that to be able to move that fast and to be able to generate that much computing power, everything else kind of fell into place. As we had these other initiatives come in place, we slowly expanded. Since then, we have about 70 servers and 60 terabytes worth of data, and we continue to grow. So that's how we did it. Thank you. Ready, Scotty? Thank you. Good luck.
Thank you very much. Is that going to reset? It'll reset? Okay, cool. Extra time. Okay, there we go. All right, thank you for that introduction. Great to be here. Great to see you all. My name is Scotty Ellis. I work for the Baylor College of Medicine in Houston with the Center for Collaborative and Interactive Technologies group in particular. We do a variety of things, basically in the public sector, particularly handling sometimes large grants, like at the moment, for example, with the Agency for Healthcare Research and Quality, pretty large website, doing lots of translational research. Anyway, so let's see how to use this thing here. There we go. Okay, so when being asked to put this together, I kind of thought about how best to talk to you all about it as other kind of public sector constituents. We use sort of a whole suite of services. You know, you can kind of see them up there on the wall. Like other people have said earlier, if you caught any of the very informative and useful sessions a bit earlier in the Compliance Summit, stay in close with whatever compliance people you talk to, and try to talk to other stakeholders at Amazon to kind of build up an idea of what services you can possibly use, depending on what your compliance requirements are. We were with a private hosting provider for a number of years, and after I got involved at Baylor about 4 years ago, I knew that cloud technology was becoming more of a thing, and so I decided to look into Amazon Web Services as a potential partner. It became quickly evident to me that they were far ahead of the game in terms of compliance. And after talking enough with their security and compliance people, it was pretty much a done deal, and we started moving our stuff more into that actual direction. In terms of our work, HIPAA compliance and FISMA compliance, so working with system security plans, if any of y'all in the audience do that, was a very big thing we had to do, and that's gone really, really well, actually, with Amazon. The way we do it essentially, for example, for websites and applications, is we started pretty small. So we started primarily with EC2, VPC, and IAM, and just sort of built with custom code things that we needed to see, and then essentially generated documentation as we needed, and then worked with our partners accordingly, essentially to fill things in. As we found, as you can see on our list, we have better security than we had before moving into the cloud. We have way better functionality. We have more quick time, basically developmentally in terms of getting things done. So it's actually been a huge win-win. We actually save money too. So let's see, what else? As other people have said also, really the key is automation after you sort of work out your appropriate compliance requirements and work out any kind of vendor and partner relationships you may need. Infrastructure as code, automation, those things are here to stay, in my opinion. They're a really big thing. And the fact that you're here is, I think, a really good sign as well. So let's see, other than that, kind of getting everyone on my team, kind of in the technical services group, up to speed in terms of like what the services are, like not just actually having them be like lettered acronyms, but having them actually know, like, oh, simple storage service, I can put this in there, or I can't put that in there, or, I need to use a relational database, for this application. Will that work for me, compliance-wise, things like that. Kind of bring people up to speed bit by bit has been very, very successful and very helpful for everyone involved. And I suppose that's about it. Catch me next door for a while if you have any questions for me. Thanks. Noah is up next.
Thanks so much. All right, thanks to Baylor and to everybody who participated in the summit today. So we've been here for a few hours. Thank you so much for sticking with us. And I'm Noah Cunin. I'm the Infrastructure Director of 18F, a team in the General Services Administration. I'm going to be joined by my colleague Rajat here in a few minutes. But since we are at the end of the day, let's do a quick survey and some physical exercise at the same time. Raise your hand if you want to hear about how we are going to fundamentally repair the digital infrastructure of our civilization, of our government. Raise your right hand up really high, kind of stretch it out, get that back cracking. Okay. Let's say you're tired, it is the end of the day, you want to get to the bar, that's fine. You just want to kick back and look at some hilarious GIFs. Somebody's already raising their hand, you don't even know the question yet. You just want to look at some nice GIFs, right? You just want to surf the internet. Raise your left hand. Check out Reddit if you're interested in that. Okay, who wants to do both? Because that's what we're going to give you. So, the subject of my talk today is bureaucracy hacking, our way to the cloud. Our here is referring to the federal government, but it can apply to anyone who's working in a high compliance environment. And the government, just like this cloud emoji indicates, we've been a little bit slow to adopt the cloud, but we're getting faster, and we want to talk to you about how we're doing it. So first to back up, because many of you might not be familiar with the US federal government's digital posture right now, or the 18F team specifically. We actually got our start with the Presidential Innovation Fellowship Program. And if you're not familiar, this is a great initiative we started in 2012 to bring the best and brightest into government for these short tours of duty. And they'd work on projects with the potential to save lives, save taxpayer money, fuel job creation, and generally make government better. And I shouldn't have to describe, especially to this crowd, government, when it comes to digital tech, needs a lot of help. Eventually, we realized that these short tours of duty weren't enough. If we didn't operationalize this innovation, if we didn't bake it into our fundamental day in, day out, why were we doing it? So we started looking around for a permanent home for these kinds of people. And one of the places we found was the General Services Administration, or the GSA. GSA is a federal agency. We employ about 20,000 people across the country, and we handle government-wide policy, real estate, procurement. It's basically the admin, operations, meta team across government, and increasingly, we're starting to do direct technology services, which is great. So in March of 2014, we had a group of Presidential Innovation Fellows and a couple people who were already part of government, myself included, who started the 18F team. We started with about, 15 people in March of 2014, and we just hit 150. So it's been a tremendous amount of growth for us, and we're well on our way to doubling again. So again, what is 18F? Ultimately, we're a digital consultancy. We're for the US government, we're US government employees, right? But we're inside. So we're transforming that government culture from the inside out. We're doing that via a couple ways, via infrastructure, via consulting, and of course, software delivery, right? Delivery is fundamentally our strategy. We need to be able to show people how this technology actually works, not just writing memos and compliance documents telling them that they should do X or they should do Y. And for those of you who are wondering about our name, it's just a coincidence. The only name the lawyers would let us have. We happen to be on the corner of 18th and F Street in Washington, D.C., so it was an homage to 30 Rock. That was a very long set of meetings. In any case, a little bit more background about where I'm coming from on this subject. Again, I'm the infrastructure director of 18F. I'm actually now based out of our San Francisco office. So if you're in the Bay Area, we have open lunches on Thursdays. Please come on by. Happy to talk to you at the session after this about how to participate in that. Previously, though, I was at the Sunland Foundation, which is a think tank in DC that focuses about technology and accountability and transparency in government. And after that, I worked for the Consumer Financial Protection Bureau. And it might not seem like it, but there was actually a straight line from working at this nexus to the areas of security and privacy and compliance, and we'll go into why that is in a moment. But enough background, let's get to what we're all actually interested in doing, which is shipping software. That's what we want to do, and compliance is often the way. So again, in our naivete, even at my last agency, the CFPB, and at 18F, we thought we just needed to hire the right people and have the right product. And that was it. That was the problem. That's why government was bad at this. They just didn't have the right people yet. They didn't have the right product. So what's missing from this picture? Cargo ships. Let's get some cargo ships out in that water, right? That's the industry's new hot metaphor for shipping software in production. So what happened? Well, we ship into production and this happened, right? And again, I don't need to recount healthcare.gov, state, immigration, OPM. The list goes on, right? But what happened? We thought we had fixed it, right? Why was this still an issue? Why were we failing across the board at shipping into production and keeping our software safe and secure? Look, this isn't rocket science, and we should know we have most of the rocket scientists in government. Well, one thing that's important to rocket science and also important to software is having a launch checklist. So maybe that was the problem, right? Let's take a look at our launch checklist. Maybe there's something we're missing there before we ship. Okay, let's take a look at it right now, in fact. So the first thing you want to look at is record management. That makes sense. You want to keep your records straight. Well, those records actually have a schedule. Sometimes you need to ship them into the National Archives for permanent preservation. That makes sense. And of course, then you need to be considered in the Privacy Act. You don't want to ship somebody's social security number, and you don't want to keep that unencrypted. Well, of course, how did you get that data to begin with? That invokes the Paperwork Reduction Act. And then, of course, you need to be thinking about Section 508 and accessibility standards, the Federal Acquisition Regulation, the Anti-Deficiency Act to manage the money you've spent in buying stuff and hiring people. And of course, then that invokes the Economy Act, the E-Government Act, the Computer Matching Act, the National Cyber Protection System, the guidance for agency use of third-party websites and applications, social media and web-based interactive technologies, the Office of Management Budget Circular A130 Appendix 3, the Federal Information Security Management Act, the Federal Information Processing Standard FIPS 199, 200, and 140-2, an important one about encryption. Well, of course, then you need to look at Special Publication 837, -53 revision 4, -60 volume 1, the infamous volume 2 of 800-60. And then, of course, you need to be looking at Special Publication 800-18, -137, -171, 133, 95. You need to be looking at Einstein compliance. You need to be looking at FedRAMP. You need to be looking at a different set of restrictions around OMB guidance on third-party websites and applications. Of course, OMB memo M-14-04, 15-01, and they are publishing those all the time. As you can see, those are dates. And of course, the Trusted Internet Connection 2.0 reference architecture. What's missing from this list? Anyone want to shout it out? I'm not going to repeat that one on the mic. There's nothing about software quality assurance. There's nothing here about software engineering. There's nothing here about load balancing or load performance testing. In fact, how much time would you need to go through this process to have time for that other stuff? Does anyone want to guess how many pages this is? And yes, I've read everything twice, and I counted. Yell it out. 10,000. A little bit high, but it is 4,006 pages. And this is across government. This isn't referring to any particular agency standards or practices or guidelines, or even your team, right? This is the stuff that's across government, so you are looking at more than 4,000 pages. This is to ship anything of importance in government. So reading all this stuff may be some weird Talmudic scholar of federal IT compliance, right? But it, again, doesn't speak to software quality, assurance, and performance. Okay, so we don't have one of these. We don't have a time machine. So my developers that I would hire in a government, they'd want to know, okay, well, we got to do it. How long is this going to take, right? Now, it may not be all that surprising to you that government doesn't keep performance data on this, but I've worked across a pretty big swath of federal government over the past 5 years, 18 if we partner with other agencies. We've worked with over 20 now. So I've collected a fair amount of anecdotal data of how long it takes to ship a major release, a 1.0 or a 0.1, right? Would anyone like to guess how long that process takes? Ooh, so close, yes. 6 to 14 months on average, and there are a lot of outliers past the 14-month mark. Again, I shouldn't have to explain to this crowd why this is just, a death-dealing blow to the government's agility around technical software. It's also a death-dealing blow to morale. After that process, this is what my dev team looks like, right? They're not ready to jump on the next thing or jump on a 2.0. They're done at that point. So again, when we talk about compliance, right, we shouldn't need to link it to agility and velocity, right? But that's more often than not the reason why we fail. We don't have enough forward momentum to correct, right? It's part and parcel of that failure around shipping that we talked about earlier, right? If you don't want to get hurt, don't get hit, right? Speed is the new security here. It's the time to patch. It's the time to rebuild from a clean baseline. It's the time to correlate, a log or a sensor. If there's one message you take back to your managers or your team from this conference, this is the message I want to send to you, right? And I want to show that the federal government is starting to think like this too, which is great. So let's now deep dive and focus on one of those checklist items I showed you earlier. and start reframing it as a capability we need to increase our agility all around. Do you see him like wiggle at the end there? Yeah, it's pretty fantastic. So that last item on the list was the Trusted Internet Connections Connection Policy. This is the reference architecture document. It's version 2.0. There's lots of reasons why this policy came to be in the federal government, but long story short, our network policies were a mess. We didn't have visibility. We didn't have transparency. One of the speakers earlier talked about the main issue with being in a classical data center is the lack of transparency and visibility. We were suffering from serious issues on this level at our network layer, so we decided to start to fix it. And this policy has a lot of good practices in it, but the problem is it wasn't written for the cloud in mind, right? There's a single appendix in here that talks about the cloud at a very high level. This doesn't give me, as an engineer, a lot to go on, right? What's even worse, right, is the actual controls that were promulgated don't map back to the risk management framework and the controls the federal government already uses, right? Again, back to that checklist, one of our main documents is called NIST 800-53, again, on the revision 4. Don't look at revision 3 anymore, revision 4, right? And it breaks down all of our security controls into families and itemizes it and enumerates it, right? These didn't map back, so you couldn't just look at a system that had gone through the risk management process and say that it has evidence for controls X, Y, and Z, and say that it also complies with the TIC policy over here. We want to fix that, right? And a quick aside, this is one of the most frustrating parts of compliance for me personally, is they're so high level, teams don't have a shared understanding of reality, what will or won't pass muster. For the more existentialist minded among us, I always thought back to this idea of the map is not the territory, or this is not a pipe, right? Our models of reality are just that, they're models, and they're processed through human minds. So one of the most important bureaucracy hacks we had is before we laid any code or any infrastructure as code down, we needed to have a shared understanding of what was gonna pass, right? Not do it, do the tests, and then who knows if it's gonna pass and get a green light, right? These conversations are extremely time consuming. And that's what 18F and GSA is doing for the rest of the federal government, is taking on that investment up front, right? So we can accelerate government's agility going forward. Specifically, with the TIC policy, we created a FedRAMP TIC overlay so we could start addressing these crosswalks and actually create technical implementations, right? So again, by pushing that definitional or semantic work first, but combining it with actual technical prototypes, we're hoping to radically increase the government's use of modern infrastructure and specifically modern networking practices. So again, I'm going to throw it to my colleague Rajat here in a moment. Again, we're going to be next door. If you're interested in working with 18F, let us know. We're very active in the open source community. Really easy to find too. We're 18F everywhere. So if you're on GitHub, find us there, and we hope to see you soon. Rajat?
Thanks, Noah. Hello, good afternoon. My name is Rajat. I serve as the security officer at Bell 18F. But I'm here today to share some of the lessons learned by going over the TIC overlay pilot. AWS will offer a number of managed security building block-like services. Some of them are CloudTrade, Cloud Config, VPC, CloudWatch, Trusted Advisor, and IAM. Using these building blocks, I'm very confident to say that the information systems can be TIC compliant. For example, using the AWS config service, they actually satisfy a number of TIC controls, involving inventory, ownership and awareness, configuration and change management. AWS VPC, which is one of my favorite services. Basically, in here, VPC Flow Logs was recently introduced maybe 3-4 months ago. With this service, one could actually configure network flow logs to a VPC or to a subnet, or even down to an EC2 instance network NIC level. The following example will actually lets us know. This is actually a code that we developed in-house. Right now, when one will actually configures network flow logs, they actually go to CloudWatch logs, and for us to will actually feed those logs into DHS. This script will assist us in getting those logs per NIC in JSON format. If anyone is very interested, please do let me know, and I'll get more information for you. Regarding the operating system and application monitoring itself, we use an open source tool called OS Query. Regarding what next, I'm actually looking at number of initiatives in the sense like fine-tuning our CloudWatch, like what we receive monitoring and like alerts, and we're also participating with AWS Game Day in terms of contingency planning and incident response. And finally, we want to get to a place where we want to visualize the data. But as in, there are so many logs from S3, ELB, you name it, like C2 and so on. So we want to pick the needle from the haystack and not, run, chasing our tails, so to speak. So that's where we want to get. And with that, I would want to give it to Jennifer from AWS. Thank you.
And today, I want to thank everybody who's here for public sector, coming to reInvent. I also want to thank 18F for participating in this pilot with us. So what I'm going to talk about is how we can use AWS to enforce the TIC, or Trusted Internet Connection, and for security requirements. And as you heard from Noah's presentation, there's multiple requirements that federal agencies have to comply with. It's a security and compliance challenge. And to give you a little bit of history, I used to work for the federal government. I worked for the Department of the Department of Health and Human Services. And several of the challenges that we had was, I supported the CDC, the FDA, and NIH, and a lot of them had big research. They had to promote public health information across the nation. And the way that the government moved things along, as Noah said earlier in his slide, was that it was a long process. And so in 2011, the Cloud First policy came out. And that allowed the federal government to start moving their workloads to AWS. It allowed them to utilize the innovation, the agility, and the flexibility to advance their mission-critical systems across the nation. This was huge. Well, as you saw the long list of security and compliance challenges, every federal agencies, they have to comply with FISMA. And so what came about was that if an agency was going to do business with AWS, they had to comply with the Federal Risk Management Authorization Program, which standardized the authorization for cloud providers. And I was part of the team at HHS who worked together with AWS and their security compliance team when they went through their FedRAMP audit. It was a 6-month process, and it was done successfully. It was rigorous, going over 300 controls from the NIST 853 revision -3. So it was very complex, but AWS worked with us, and they understood our requirements, and they were successful. And AWS happens to be a compliant cloud service provider. Today, many federal agencies are using AWS today to run their sensitive workloads to advance their mission-critical systems. So what am I going to be talking about? A lot of people heard about AWS participating in the FedRAMP TIC overlay pilot. And what I want to talk about is what we discovered and what we learned from this pilot. Was one, that we started with a baseline, understanding what these requirements were and what the security challenges are. 2, we wanted to identify a way of how we can help our customers enforce these TIC compliance and security requirements using AWS. And 3rd, we wanted to make this automated. How can we take this and make this automated so that our government agencies can focus on what they really want to, which is their mission. So I'm not going to go into detail with the trusted internet connection since we already went through that with Noah's slide. It's basically another security and compliance requirement for federal agencies. It's a mandate that all agencies must implement, and it requires them to implement an architecture so that they can monitor what is happening within their network going to and from across their federal agency space. And how do agencies comply with the TIC today? Well, one, they can either build it, so that requires resources, a consistent budget, so that they can pay for the operations and maintenance of it. Or two, they can contract that out and depend on a carrier to do this for them. Or three, work with an agency who has already implemented TIC. The problem with that is that when you're working with cloud computing, it wasn't very efficient. And we're going to talk about why it wasn't. So here we go, and you saw the previous slide deck of the proposed FedRAMP TIC overlay. Right now, the way that agencies are connecting to the cloud provider is that they have to go through their agency network to their TIC provider and then to the AWS cloud. That's a lot of hops. That causes a lot of performance issues. And when you're working with an agency like HHS, and you're trying to get the information out to the public, such as, is there anything that they need to know about public health? The speed of information is so critical, and without that, it causes challenges. So FedRAMP got together with the Department of Homeland Security and said, let's figure this out. And going back to the point that the risk management framework is the baseline. So why not use that? And so what they did is they got together and said, let's look at your security requirements for FISMA, and let's look at the TIC capability security requirements, and let's merge them, and let's create this overlay so that we can have agency users remote directly to a TIC-ready cloud provider. And what do we mean by TIC-ready cloud provider? What we mean is that we have AWS who has the capabilities to enforce the TIC security requirements that agencies must comply with so that they have that level of assurance to, one, secure their network connections as well as being secure with their data in the cloud. So the future state looks like this, where you have an agency user remoting directly to AWS, knowing that we already meet those TIC capability requirements into their TICAP or their MTIPS provider, and then through their agency network. Working with 18F, we went through this baseline. We tore it apart, working together with not only our customer, but we also worked very closely with our third-party assessor, the Veris Group. DHS, the Trusted Internet Connection team, was also part of this pilot, and we evaluated the AWS FedRAMP authorization, which is based on the NIST 853 controls. And we mapped them to the TIC capability controls to see, what are the similarities here, and does it really qualify to this TIC assessment? And from the initial assessment, working through this, we realized that we already meet over 80% of the TIC capability controls. That's pretty awesome. So what that tells us is that we can enforce TIC with our customers. We can manage that for our customers inherit that. And then as we go through the exercise with Veris and DHS, we realize that for our cloud, for AWS, actually 55 of those capabilities actually apply to us. And that from 12 of them was the responsibility of the customer. And I want to talk about the AWS shared responsibility model, because that's our foundation for security and compliance within AWS, understanding what AWS brings to the table as far as ensuring that you have that you understand that we meet those security requirements. We provide that for our customers. And then understanding what the customer is responsible for and providing them the means to ensure that they can enforce them. So from there, we were able to identify those 12 controls related to the TIC that our customers needed to enforce. And from that, we worked together with our solution architect, Alan, who's in the audience right there. And we built out these test plans because what we wanted to do was, great, we've identified these 12 controls that needed to be enforced. So what does our customer need to do into AWS to ensure that this happens? And we wanted to make this easier, so when they go through a tick assessment, they have this step-by-step guidance on how to enable this in AWS. So DHS is like, this is great. We've got a baseline. We understand the shared responsibility matrix. We understand that we've got a tick assessment plan that we can give customers so that they can use it to enforce their tick compliance. But we also require our agencies to capture and audit their flow logs. What can AWS do for agency customers? That was simple. We already provide these services. And right here you can see that through AWS Virtual Private Cloud, the Elastic Load Balance, Simple Storage 3, CloudWatch, CloudTrail, and even Identity and Access Management are key services that helped automate these features. And the interesting here that I want to point out is that these services are available to our customers today, and it satisfies more than one tick capability control with a single configuration change. That's pretty impressive. So in the next coming months, I want you to be on the lookout. We are going to be working on having a white paper on the use case to provide best practices around tick enforcement for our customers. We're also going to provide automation. Automation is key. And we're going to be working with our solution architects and developing that and providing those resources to our customers towards the end of this calendar year. We're also going to be providing various network connections to the tick so that agencies know how to connect to the AWS cloud and enforce their tick compliance. We've concluded our pilot. We've submitted our reports to DHS and FedRAMP, and it's been successful. We've completed phase 1 of what they were trying to resolve, and we proved that AWS can enforce tick requirements that agencies need to comply with. So if we can imagine, if we can get tick certification, if we can be a tick-ready CSP and have one federal cloud computing compliance framework, that's going to help a lot of agencies move to the cloud. Not only help them move to the cloud, but give them the performance of what a true AWS cloud should be like. The speed, we talked about speed, the speed of information, but also the security of that, and we can provide that. So for more information about the tick pilot and what we've done, feel free to email AWS Compliance. And if you want a copy of the FedRAMP tick overlay, it's publicly available on the fedramp.gov website. Thank you.